Hello everyone, this is Steve. If I want to graph h of x and s of x here, a transformed exponential with a base of 1/2 and a transformed logarithm with a base of 1/2, I should start by finding some ordered pairs on the original exponential and the original logarithmic graph. So, the exponential function 1/2 to the x, we can find three key ordered pairs on that. -1, 2, 0, 1, and 1, 1/2. Its inverse function would be the logarithm graph with the exact same base, and we can find its ordered pairs just by swapping the three we found for the exponential. In other words, 2, -1, 1, 0, and 1/2, 1. All right, now we are ready to find some ordered pairs on both this h of x and this s of x. So here's what we're going to do. We need to figure out what's changing here. So we've got this negative sign in front, we got this +1 up here and this +2 here. So we are, because of the +1 next to the x, we are going to subtract 1 from every x value. Let's do that first. So that's going to become -2, -1, and 0. Then the negative in front is going to change every y value to a negative, and then we're going to add 2 to them. So if we change every y value to a negative, then the 2 becomes -2, but then we add 2 and it becomes 0. We change the 1 to a -1, but then we add 2 and it actually becomes a 1 again. So I did change it, it just didn't actually change. And then the 1/2 gets hit with a negative, -1/2, add 2 to that, we get +1.5. Okay, we come over here. X and y, what's going on here? We've got a negative on the inside, which looks a little bit fishy, but all that's going to do is change the sign on all the x values. And we have a -1 on the outside, which is going to shift the whole graph down 1 unit, subtract 1 from all the y values. So change sign on x, subtract 1 from y. So if I change the sign on every x, it's going to become -2, -1, -1/2. And then if I subtract 1 from every y value, it's going to become -2, -1, 0. Okay, that should be enough to sketch some graphs, so let's do that. So h of x is an exponential graph that has been shifted to the left 1, then reflected over the x-axis, then shifted up 2. Let's plot some ordered pairs. So -2, 0, right there, -1, 1, right there, and 0, 1.5. So right there. So what happened? Well, it reflected over and shifted up 2 units. So our horizontal asymptote is right here now at y equals 2. And the graph looks like this. Now the domain is still -infinity to infinity. That hasn't changed, but we do have a new range, and our range is going to be -infinity up to 2, not including 2. So that's our exponential graph. Has to have a horizontal asymptote because it's exponential. Just like our logarithm graph over here is definitely going to have a vertical asymptote. So let's figure out where that is. So by plotting the points. So -2, -2. So right there, -1, -1, right there, and -1/2, 0. Well, this graph reflected over the y-axis, and then it shifted down 1 unit. So the vertical asymptote didn't actually move, everyone. We're just on the other side of it. So the vertical asymptote is still here at x equals 0. It's just that the graph is over here. Meaning the range hasn't changed. It's really hard to change that range of -infinity to infinity on a logarithm graph. But the domain has changed because now our domain goes from -infinity all the way up to 0. So there's our transformed exponential graph and our transformed logarithm graph. I hope that helped. Thanks for watching.